Every revolution brings power and thrill. Artificial intelligence is no longer a tool sitting quietly in our servers. It's making judgments, writing codes, approving loans, and influencing human destiny. The question isn't what can AI do, it's what could go wrong and who is accountable when it does. Welcome to this series on AI risk. The agenda for the complete series is as shown. In this opening chapter, we decode what AI really means from a risk perspective, why it's unlike any risk we have known before, and why governance, not genius, will decide whether AI evaluates us or endanger us. The detailed agenda for this part of the video is as shown. Welcome and namaskar. This is your host Savit Vittal Salian. Let's start the journey. Artificial intelligence has crossed the threshold from automation to autonomy. What began as an algorithm assistance in finance, healthcare, and logistics is now shaping languages, judgment, and even moral reasoning at scale. Each wave of capabilities, from pattern recognition to generative cognition, has expanded both potential value and exposure to risk. AI risk, therefore, is not a single failure mode. It is a multi layered interplay of technical, ethical, operational, and systemic fragilities that challenge traditional governance. Where classical enterprise risk focuses on known unknowns, AI introduces unknown unknowns like emergent behaviors, feedback loops, and self reinforcing outcomes that evolve faster than policy can adapt. As called out by few experts, control problems amplify with capabilities, and humanity must architect the futures deliberately, not drift into them. Let's understand this in depth. Control problems amplify with capabilities. This means the smarter and more powerful a system becomes, the harder it is to control its behavior safely. So, when a system gains capability, the ability to act autonomously, make decisions, learn, or affect the real world, our ability to predict, limit, or correct what it does gets weaker. So, as capabilities goes up, control gets harder. It's like saying the faster the car, the better your brakes and steering must be. So, why this happens? Well, there are three main reasons: complexity, autonomy increase, speed and scale of increase. As systems learn more and make independent choices, it becomes difficult to foresee all possible outcomes. That's the increase in complexity. When the system starts making decisions without asking for permissions, humans become out of loop. This is a case where autonomy increased for the system. When the system acts faster and across larger networks, smaller mistakes spread widely before a human can intervene. That's speed and scale, the increase of it. Let's take some examples. Say car versus self driving cars. Regular car moves only when you press the pedal. You are in full control. Whereas self driving cars decide when to brake, when to turn, or when to accelerate. If it misunderstands a signal or faces a new situation like a hand gesture from a traffic cop, the human has less time to correct it. Hence, more capabilities, harder the control. Let's take a second example: calculator versus machine learning models. Calculators follow fixed rules, there are no surprises there. Whereas machine learning models finds its own pattern from the data. Now, if the data contain biases, it will learn that bias and human might not notice until a harm has occurred. Again, more capability, more uncertainty in the outcome. Let's take the next case of drone versus swarms of drones. One drone can be piloted easily. Now, say swarms of 100 drones with AI coordination can adapt, self organize, and respond to the environment. But predicting how all 100 will behave together is exponentially harder. This is a control problem amplified by scale and autonomy. Next is chatbot versus generative AI. Early chatbots followed a scripted response, whereas generative AI creates new texts, images, or code that never existed before. It's powerful, but it can also fabricate facts, what we know as hallucination, or can produce harmful content unintentionally. It's the same creativity that makes it useful, also makes it unpredictable. Here, capability creates creativity and also a risk. In AI terms, as AI systems evolve from rule based to learning to adaptive to autonomous and self improving phases, the control problem evolves too. For simple monitoring, from simple monitoring to complex alignment challenges. Here, are goals still consistent with human intent? That's the challenge. The next challenge is, can the system explain its reasoning? The third challenge is, can we safely override or shut it down? That's why researchers talk about alignment and containment. Ensuring capability doesn't outrun the control. So as machine gets smarter, our job shifts from programming them to governing them. The next phase that we have seen earlier is, humanity must architect future deliberately, not drift into them. It means we must plan and design our future with intention instead of just letting it happen by accident. If we don't actively decide how we want technologies like AI, genetics, or automation to shape our society, those technologies will still evolve, but without our moral compass. So we drift and would end up somewhere we never meant to go. Why this matters? Well, think of the difference between architecting and drifting. Architecting is designing something with a blueprint, a purpose, and checks for safety. Whereas drifting is floating wherever the current takes you with no control or destination. In the context of AI and technology, the quote warns us that if we don't build rules, values, and safeguards now, we might wake up in a world designed by accidents, not by ethics. Why this matters? Well, the future is something you create, not something that happens to you. So, intent beats inertia, should beat inertia. Next is, technology should serve human values, not the other way around. The design needs directions. If you don't steer, progress might move faster than the wisdom. So, ethics must lead innovation. Let's take an everyday analogy, building a house versus living in a floodplain. An architect would choose materials, structure, and drainage so the house could last for decades. Whereas a drifter would build wherever it's easy without planning. So, when the storm hits, one house would stand, the other would collapse. You know which one would do that. The future is the same. Designing it or be swept away by it is our choice. Next case is driving a car versus coasting downhill. If you hold the steering wheel, you choose the path. But if you let it go, gravity and momentum decides where you go, maybe into a ditch. AI and technology are like powerful cars. They need drivers with foresight. Next is, say, let's take an example from social media. When social media started, few planned for misinformation or mental health impact of social media. We drifted. We drifted into a world where attention and outrage were rewarded more than the truth. Isn't that the case today? If society had architected deliberately with safety, privacy, and education in mind, the impact could have been healthier. From an AI example perspective, generative AI can write, draw, or code, but without deliberate design, it can also amplify biases or spread falsehoods. So, if we drift by just scaling faster, we may get powerful tools before we are ready to govern them. Hence, architecting the future means building guardrails, ethics, and accountability into AI before it's everywhere. Deliberate futures are built by design. Accidental futures are built by neglect. Let's take a case study. Let's say a university launches a new AI platform to help with student grading. Now, if they architect deliberately, they will check for biases, they will involve teachers in oversight, they will explain how the system works and ensure student can appeal a decision. Now, if they drift, they'll just switch it on because it's convenient and later discover it unfairly penalize certain groups or makes unexplainable grading mistakes. Now, the technology is the same, but the intention behind deployment changes the outcome. So, the future isn't something we find, it's something we build. And if we don't build it with care, someone or something else will build it for us. So the question is, am I a passenger in the future of AI, or am I helping design where it goes? So AI risk can be defined as the possibility that AI systems, through its design, data, deployment, or diffusion, generate outcomes that are misaligned with intended goals, human values, legal obligations, or systemic stability. The definition extends beyond technical malfunction. It includes technical, ethical, operational, and strategic. Model biases, brittleness, adversarial manipulation, data drift are technical. The impact in this could be erroneous credit scoring or misdiagnosis. The next is value misalignment, discrimination, opacity. The impact here is reputational and societal harm. These are ethical malfunctions. There could be deployment errors or lack of monitoring or drift impacting service disruption been caused or breaches in the regulatory aspect. These are operational malfunctions. There could be concentration of capabilities or autonomy without oversight, causing financial contagion or misinformation could cascade across. That's strategic or systemic malfunction. Hence, managing AI risk requires interdisciplinary vigilance, combining model governance, human oversight, and ethical foresight. So, why AI risk matters now? Well, AI now powers decision in lending, recruitment, trading, and surveillance. Many more, of course. Each domain carries regulated obligations. Could be from fairness perspective, explainability perspective, or privacy perspective. These are pervasive adoption. AI risk matters now because of regulatory convergence. Frameworks such as the EU AI Act, the NIST AI Risk Management Framework, or ISO 42001, and India's DPDP Act are transforming AI compliance from advisory to enforceable. AI risk also matters due to societal visibility. As experts highlight, AI's extractive resource and labor footprint is reshaping ethics and geopolitics. AI risk matters due to capabilities diffusion, which is, as experts warn, open models and democratized compute erode containment, thus multiplying misuse risk. That's capability diffusion. AI risk matters now due to existential dialogues. The Future of Life Institute's open letter of 2023 catalyzed a global pause and reflect moment. Safety research must precede scaling. That's a existential dialogue. Now, for the banking, financial sector, insurance sector, and other critical sector, these forces converge into one imperative: trustworthiness at machine speed. So, how AI risk differs from traditional IT risk? Well, we can look at it from five aspects. The first is source of uncertainty. In traditional risk, these are system faults or cyber attacks. In AI risk, it's model behavior, data bias, or emerging autonomy. The next aspect is predictability. In traditional IT risk, it is deterministic, but in AI risk, it is probabilistic or stochastic. The next aspect is life cycle control. It is stable software version in traditional IT risk, but in AI, it is continually learning and has drift. Accountability is the next aspect, wherein traditional IT risk is human coded decisions are made, but in AI, it is machine generated decisions. The next aspect is the mitigation approach. In traditional IT risk, there is security and compliance audit. But in AI risk, it requires continuous validation, explainability, and ethics. Thus, the risk perimeter expands from infrastructure to intentions, from what systems do to why they do it. Let's look at a multi-level nature of AI risk. Well, AI risk manifests across three interlinked levels. Micro level, these are model levels, which constitute biases, robustness, adversarial threats, explainability gaps. The next level is MISO, or the organizational level, wherein we have governance, accountability, operational resilience, and regulatory compliance. So that's the second level of risk. The third is macro, which is societal level, which is about employment displacement, misconfiguration, and concentration of power, sustainability. So each level requires distinct guardrails but unified oversight. An expert has quoted that the real danger is cascading fragility, not single point failure. Let's look at this in a different perspective. AI systems that face different kind of risk at different levels. So each level needs its own safety measures. Safety measures are guardrails. But even though the risks are different, one oversight structure must connect them all. Because if one layer fails, it can trigger failures in the other, like falling dominoes. Different protection, same supervision helps to avoid chain reactions. Let's look at levels. We discussed this. Level 1 is the model, second is operational, third is societal. So at risk level, what are the risks in level 1? Well, inside the AI itself, data, code and algos. At level 2, it's how the AI is used, which is deployment, monitoring, human oversight. At level 3 is how AI affects people and societies. So what are the guardrails at each level? At level 1, you can have bias testings, explainability guardrails, robustness check as a guardrail. At level 2, the guardrails could be access control, retraining, MLOps monitoring. Whereas at level 3, you have guardrails of ethics, laws, accountability, and the important guardrail of having transparency. Each level needs its own seatbelt, but they must all be bolted to the same frame of governance. Imagine, what does unified oversight matter? Why does it matter? Well, imagine three guardrails protecting different part of a highway. One near the lane, one near the bridge, and one near the edge of a cliff. Now, if each works alone but isn't connected, a crash can jump from one to the next. Similarly, if AI technical guardrails, if it fails, the operational guardrails or operational level, which are human oversight, might not notice, and the societal levels, which is public trust, could collapse. Now, this is what happens when these are not connected. The guardrails do not talk to each other. That chain reaction is called cascading fragility. Small cracks spreading into a large failure. So, having a unified oversight matters. So, what cascading fragility means? It means it is easily breakable. One failure spread to other like dominoes or a snowball rolling down the hill. In AI, it means a small glitch at one level can trigger major consequences across the system. Let's take an airplane safety analogy. At a model level, you have autopilot software, which has misread weather data. At an operational level, the pilot doesn't notice because monitoring system had failed. So where will he look at? At a systemic level, the flight regulations assumed the software was infallible. Result? A small software error cascaded into a disaster. So that's cascading fragility. If you take the example of banking, a bank's AI credit model misjudged risk because of data drift. The risk department doesn't catch it, assuming the model knows best. The regulator later finds thousands of unfair loan rejections. A single undetected model drift spreads into a reputational crisis, causing regulatory penalties and customer outrage. That's why guardrails at each level must be strong and important, connected. That means guardrails at the model level, operation level, at governance level. Let's take a social media example. The algorithm model favors content that drives engagement. Operation teams measure success only by click through rates. The result? The society suffers misinformation and polarization. Here, the system didn't fail in one place, it failed everywhere together. In AI risk language, what's distinct guardrails? Well, each risk layer needs specialized tools and policies. At model level, you have fairness test, explainability. At operational level, you have MLOps, monitoring, and human in the loop. At societal level, you have governance policy and transparency report, some of the examples. You need to have a unified oversight. You need one central governance body to watch all levels to spot weak links early on, like an AI risk committee or a CRO. Here, a minor issue, say biased data, can trigger an ethical, legal, or reputational collapse if nobody connects the dot. That's your cascading fragility. Think of AI ecosystems like a three-story building. Each floor has its own fire alarm. Now that's a guardrail. But if those alarms don't connect to a central system, one fire can engulf the whole building. So the goal isn't just more alarms, it's coordinated safety that matters here. What are the key takeaways? AI risk doesn't explode all at once, it leaks layer by layer. Now, if those layers aren't connected by shared oversight, small leaks becomes flood. In summary, AI needs different seatbelts for different speeds, but one driver is needed who watches the whole road. Spectrum of AI risk. The first risk type is from bias and fairness perspective. Example, discriminatory credit approvals. The primary control here would be having a fairness testing and bias mitigation framework. The next risk type is explainability risk. It is about example is unpredictable, uninterpretable loan rejection. The primary control could be model interpretability tools such as shape and line. The next is robustness and drift risk. Example, model decay post deployment. In here, the control could be continuous monitoring in place or retraining pipelines. The next is the security risk. Example, adversarial prompts or model theft. The control here could be having a red teaming, access control, and watermarking. Next is privacy risk. This is about the data leakage or re-identification as an example. Here the control could be differential privacy or having a federated learning in place. Next is compliance risk. Example, breach of AI Act or DPDP or having non-compliance towards GDPR requirements. Here the primary control could be having a legal alignment in place, having audit trails, having documentation all set in the right order. Next is reputational risk. Example, like having a public backslash or media scrutiny. Here the control could be having a responsible AI communication or having a transparency report in place or a mechanism in place. The next is existential systemic risk. It's about having uncontrolled autonomy or misinformation being cascaded. The primary control around this could have to enable capability evaluation and having policy coordination. Let's look at evolving governance response. Experts suggest ethics must move from abstract principles into data labeling, metric design, and having a feedback loop in place. Others emphasize operationalization, bias testing, adversarial robustness, and explainability as a standard control. Experts stress that national or corporate isolation would fail. Having a coordinated oversight and disclosure standards are critical here. Thinkers argue that documentation, model cards, data sheets, energy footprints is a governance instrument, not a PR exercise. Let's look at the imperative of integrated risk management. AI risk cannot be relegated to data science teams. It must be integrated into the enterprise risk management framework with explicit risk appetite statement, model validation charter, and cross functional accountability. A mature organization will therefore could have to classify AI use cases by impact and autonomy level. Would need to apply proportional control like lightweight for low impact and rigorous for high impact models. A mature organization will therefore embed continuous assurance, automated monitoring, periodic audits, and red teaming. A mature organization will therefore need to maintain transparent documentation for regulatory and stakeholders, establish crisis response playbook for AI incidents. This integration ensures that AI risk governance evolve as fast as AI capability. In conclusion, AI is not merely another technology. It's a decision infrastructure that redefines responsibility. Intelligence amplification without alignment invites control failures. Our choices now determine which future would unfold. AI externalities are already planetary. What does that mean? Well, the effect of artificial intelligence, both good and bad, already stretch across the entire planet. They don't stay with one company, one country, or even one industry. AI systems are now global in scale, interconnected in impact, and environmental in consequence. So, AI doesn't just affect users, it affects societies, economies, and ecosystem. So, what are externalities? Well, externalities are the side effects or indirect consequence of an activity that affects others who did not choose to be involved. In economics, a positive externality is a side benefit. Example, free knowledge sharing. But a negative externality is an unintended harm. Example, pollution. So when we say AI externalities are planetary, it means AI side effects on energy, jobs, privacy, and truth are no longer local problems. They are global consequences. Now we'll ask why planetary? Well, because AI systems today are trained on global data collected from everywhere, deployed on cloud infrastructure spanning continent. They are used by billions of people, influencing global information, its market, and opinions. And they consume vast energy that affect the planet's carbon footprints. That's why planetary. AI's reach and resource demands already make it a planetary actor, just like climate systems or the internet itself. Example, say environmental externalities, which are energy and carbon. Like training one large AI model like GPT or image generator can consume as much electricity as hundreds of households per year. That energy often comes from fossil fuels, increasing carbon emissions globally. So, an AI experiment in California can raise energy demand in Europe and Asia. Let's take a second example of social externality, information and truth. AI generated misinformation or deepfakes spread across the internet instantly. One fake video can destabilize elections or trigger social unrest in another country. A local output causes a global ripple. Let's take a next example of economic externality, labor and inequality. AI automation can replace jobs in customer service or content creation across multiple countries at once. The benefit, profit, and innovation often concentrated in a few tech hubs, while job loss spreads globally. Global winners and losers emerge. Now that's planetary imbalance. Let's look at data externality, privacy, and consent. AI models trained on global data scrap content, photos, blogs, voice from the internet. Now, even if you live in a country with strong privacy law, your data can still be used to train a model hosted somewhere else. Your data footprint becomes planetary, even if you never gave the permission. Finally, cultural externality, homogenization of knowledge. Generative AI trend to produce content in dominant languages like English. Over time, smaller language or local tradition risk being overshadowed or simplified. The cultural diversity of the planet narrows. Silent global externality. In simple language, AI doesn't stay where it's made. It affects travel through data code, energy, and influence to every corner of the world. That's why AI externalities are planetary. They affect the atmosphere, they affect economies, they affect societies, they affect cultures. Atmosphere like energy use, economics like job shifts, societies from bias and information, cultures through language and values. So think of AI like ocean currents. You can pour something into one spot, but the waves will carry it around the world, whether it's a drop of innovation or a drop of pollution. It travels. AI's current are data flows, algorithms, and decisions. Now, once released, they spread planet wise. Why should I care? That would be a question of many. Well, because AI is planetary force now, your data, your creativity, your environment are part of it now. The next generation of professionals like you will decide whether it's a global effect, becoming net positive like shared prosperity, or a net negative like digital inequality. AI governance is not about coding, it's about climate, culture, conscious. AI is powerful enough to change the planet. So we must make sure it changes it for everyone's good, not just someone's gain. So if AI development happens in one country, but its impact is felt by all, who should be responsible for governing it? The developer, the user, or the world? Therefore, the management of AI risk must move beyond compliance into strategic stewardship, balancing innovation, trust, and resilience. It is, in a sense, the new frontier of enterprise risk governance in the age of intelligent autonomy. With this, we have come to the end of the part 1. We will be moving to the next part of AI risk typology and taxonomy. I would like to thank you for the time that you have invested for this part of the series. We end this introduction to AI risk now and move to part 2. Thanking you. This is your host Savit Vitthal Salian. Namaskar.